Now let's talk about sampling methods. To draw conclusions about a population, we rarely survey everyone. So we need a sample, but we want our sample to be a good representation of our population. Okay, that is the ultimate goal for any sample that we choose. So let's talk about, we're going to talk about 4 different types of sampling. There are more, but we're only going to talk about these 4. If you're moving on to statistics, you will learn about more than just these 4, but we're going to talk about these first, and I'm going to do my best to give you examples of them. All right, I kind of want to work backwards here to give you an idea. If for cluster sampling, let's just say this is population is our entire JCC population. The population is split into clusters, and you choose some clusters and survey everyone inside. And it's good for saving time and money. So if this is all of JCC students, and that's what I'm going to use for all of these, and we've got different clusters. So what I talked about, I think, in class is the different programs. So we had CJ, we had art, we had social sciences, we had nursing, we had STEM, it's psych, there's just so many, y'all. If this is cluster sampling, you randomly choose, and you have to randomly choose them, the clusters. So say we decide on 4 clusters. We decide on this one, this one, this one, and this one. And then from those 4 clusters, in order to do a cluster sampling, every single student in those clusters have to be in our sample. We have to collect our data from them. Now there could be issues with that, but what we're going to choose for our sampling, that is cluster sampling. Stratified sampling is when the population is divided into subgroups, or called strata, and you take a sample from each group. Now again, I'm going to draw a picture, JCC students, and this could be something different. This could be online students. Let's do online. This could be J-Town. This could be Olean. Different. You could have different methods, different ones. And if we knew what the percentage of online students were from the entire population, you can just take a percentage of the samples. Okay, not the entire sample. You're only going to want a percentage or a small group of it. If there is, you could do anything. Oh my gosh, there's so many different ones. But these, whenever you take it, somebody from each group, each strata, each subgroup, there's going to be a few people or a few things from each group. So it's going to be a percentage of the subgroup based on what the percentage is from the entire population, okay, of that subgroup. Systematic, to me this is the easiest one. Systematic random sample, you start at a random point and you pick every nth person. So if you see that every 3rd person, so remember back in school, your teacher would go along and say 1, 2, 3, 1, 2, 3, as far as numbering you, and then that's how you were put in different groups. Whenever I was driving down to Warren one time, and there was a police group were stopping people. They weren't stopping everyone. They were stopping, like, let's just say they were stopping every 6th car. So after 5 cars had gone through, apparently I was the one who got picked, and I was the nth person who was chosen to see if I was drinking. So this one's going to have a number with it. It's going to be every 3rd or every 4th or every 12th. That is going to be systematic random sampling. And then the number 1, the best way to choose a sample is a simple random sample. And it's because everyone in your population has the same chance of being in this sample. It's like drawing from a hat. Okay, there's also random number generators online that you can use. This by far is the winner chicken dinner for if you want to have a good, fair sample for your population. All right, identify the method. So we're going to looking at these four. I want you to pause the video and attempt these four and then come back to see how you did. All right. Survey every 12th name from a list. Well, this is that nth person. All right, and that is going to be systematic. Select some students from each grade. That is going to be stratified. Not everyone in like the 3rd grade, not everyone in the 10th grade. From each grade, somebody's going to be represented. So this is stratified. Survey all residents in a few chosen neighborhoods. This is cluster because it used the word all, but it's only a few neighborhoods. And then lastly is the random number generator that I was just speaking about. Chooses 30 students, and this is simple random. Everyone has a chance. Let's talk about sample bias. Sampling bias, if we post a survey link on Instagram, is that a fair sample? No, it's not a fair sample. Why? Ageism. Not everyone is on Instagram. Dudes versus chicks versus everyone. As I spoke in the previous video, dudes are less likely to fill out a survey, even if there's money involved. Dudes versus chicks versus everyone is what I said. Okay. There's many different things. I'm not on Instagram, so that would be an ageism thing. I'm primarily on Facebook. Am I going to fill out a poll? Probably not. Key idea. Voluntary online polls are not random. They're not random samples. So they're not going to be a good representation. I'm sorry, not fair, not random. And you want random. Because they overrepresent certain groups. And they underrepresent others, of course. Let's talk about organizing data. Once we have the data collected, and hopefully from a good representation of our population, we must summarize it. Raw data is messy, and you want to compile it as quickly as you can so that you can understand what you're trying to gain from that population, all right, from that sample for the population. Categorical frequency distribution, preferred pet responses. So in class, I asked for everyone to choose their favorite pet, but only given one of these responses, all right? And I did that in class. But for this one, since we're not in class right now, let's just say that these are the responses that were given in class. And the question is, how many dogs do we have? Well, for dog, we have 1, 2, 3, 4, 5. For cat, we have 1, 2, 3, 4. For bird, we've got 1, 2. And for fish, 1. Okay. So I'm going to take those numbers that I just tallied, 5, 4, 2, and 1, and put them on what's called a frequency chart. A frequency chart just tells you how many people chose dogs as their favorite pet, how many people chose cats, how many chose birds, and how many chose fish. Your total is when you add these all up. So 9, 10, 11, 12. There's 12 total data responses. A quantitative frequency distribution, instead of categorical, we've got numbers. Okay, quantitative, remember, we can actually do percentages and things like that with these numbers. So I want you to pause the video and take the daily copies consumed. I like to actually do hash marks whenever I'm doing this. So like for 1, I would put a hash mark, okay? So go through, do that, and then put your total frequencies over here and total them up. Pause the video, do that, and then come back to see how you did. All right, I have 2, 0, 3, 2, 1, 1, 4, 0, 2, 1, and 3. So frequency is 2, 4, 3, 2, and 1. The total we have is 6, 7, 8, 9, 10, 11, 12 again. That's the total. Bend frequency distribution, and this is done for larger data sets. Bends group ranges of numeric values. Example bends for GPAs are 1.5 to 2.4, 2.5 to 3.4, and 3.5 to 4.4. Here's what you need to understand. This is not just a representation of 1.6 to 2.3. This is truly a representation where 1.5 and 2.4 are included. So that shows you down here, important endpoints matter. They are part of it. So if you have the 2.5 to 3.4, that means the GPAs that we're looking at, it's got this equal sign, so it includes 2.5 and it includes 3.4. Okay. All right, now we've got some practice. It says identify the sampling method. A university with 6 dorms randomly chooses 2 dorms and surveys every resident. I want you to pause the video and do this section here up until identify the unit to make sure that you have a good understanding of what we're doing here. I'll go through and fill it out, but I want you to pause the video, do this yourself for a practice, and then come back to see how you did. A university with 6 dorms randomly chooses 2 dorms and surveys every resident. So that's going to be cluster sampling. To classify the data, what does this look like? Is it going to be quantitative? Or is it going to be categorical? Remember, categorical is also qualitative. All right. So number of siblings, that's a number, but is it a label or is it something you can take the average of? That's my question I always think of. And I could take the average of number of siblings in our class, so that's quantitative. Eye color, no number there, so that's categorical. And lastly, zip code. I was speaking to this in the previous video. Zip code, even though it's a number, you can't take the average of zip codes and find it and have something meaningful. So this too is categorical because it is a label. All right, create a categorical frequency table. This is the raw data, and this is going to be based on grades, I'm guessing. And the grades, it looks like no one can fail. So we've got A, B, C, D, and then total. We need to count how many A's, count how many B's, C's, and D's, and then take the total. And this is called a frequency table. So 1, 2, 3, 4 A's. 1, 2, 3, 4 B's. Consistent. C's is 1, 2, and 3. And D's are 1, oh, just 1. And again, 12 for our total. All right, now let's start something new. Identify the unit. We did a little bit of unit discussion earlier. It says for each scenario below, identify the unit being studied. So this is something you can check as well. A survey asked people at the mall about their shopping habits. What is the unit? So the unit is what we're asking. We're asking people at the mall. A biologist measures the wingspan of 40 butterflies. The unit is the butterflies. That's what he's measuring, or she. A streaming service analyzes user watch time. Well, the users is the unit. Going the wrong direction. There we go. All right. Looks like all of this is practice. Fantastic. Identify population and sample. For each description, label the population of the sample, and that's for these two here. So go ahead and pause that. And actually, you can do all of this. Go ahead and do this entire page. This is really preparing you for understanding this material. I'd rather you do this and make sure you understand it before I just start spieling. So please pause the video, attempt this yourself, and then come back to see how you did. A university wants to know the average screen time among all students. So they randomly survey 200 students. Well, the population is the all students. The sample is the 200 students. A company tests 50 laptops from a shipment to estimate defect rates. Well, the population has to be all laptops, all or every, pick a word, because our sample is the 50 laptops. Decide whether each measurement is a parameter or a statistic. Now remember, the parameter is a representation of the data collected from the population, and the statistic is the same information but collected from a sample. The average GPA of 60 surveyed students is 2.9. Again, they're using the word surveyed, and there's only 60 students, so this has to be a statistic. The actual average GPA of all students at a college is going to be a representation of a parameter, because that's all students. 38% of the sample prefers online learning. Again, they're using the word we need to see to let us know this is a statistic. And lastly, the true percentage of all voters who support a new law is a parameter representing the population. All right, categorical versus quantitative. We're going to answer in categorical or quantitative. They both can have numbers, but categoricals would be labels. Quantitative is numbers that you can actually have meaningful calculations with. So number of video games owned. You can easily take the average of that for our students. So quantitative would be that. Quantitative. Favorite pizza topping. Well, that's not a number, so that's categorical. Age in years. We can take the average of the age of our class, so that's going to be quantitative. The zip code we've had before. You could also say Social Security number. We could say J number. There's just so many opportunities here, so that's categorical. And the number of pets. It's a number, and can we take the average of it? Yes, we can. So that is quantitative. All right, identify the sampling method. It's simple random, which is the best option. Systematic, which has your nth person or nth item. Stratified, where you choose a little bit from each group. And then cluster is where you've got multiple groups, and when you randomly choose a few groups, everyone in those groups have to be in it. If it doesn't meet any of those four with what we're just doing here, not for your next stats class, then it's going to be not a random or a biased sampling. A school divides students into freshmen, sophomore, juniors, and seniors. So we've got 4 grades, and randomly selects 20 from each group. Well, that is going to be what? That's going to be stratified. A researcher selects every 12th name. That's going to be systematic. That's all I need to see for that one. When I'm done with this little piece, I'm going to pause. Maybe? Yeah, I'm going to pause. A city is divided into neighborhoods. The researcher randomly picks 5 neighborhoods and surveys every household. That's cluster. A coach puts all players' numbers in a hat and draws 10 at random. That is simple random. Everyone has a chance. And then a website posts a voluntary poll. Anytime you see voluntary, that's not good. Asking visitors, do you support a ban on plastic bags? This is going to be not random or biased. All right, I'm going to pause the video. When I come back, we'll talk about tables.